Yes, sir.
Okay. Now, today we will start the new problem. The name of the problem is majority finding problem. So, majority finding problem uh, means what? See, suppose you have been given an array, capital A, suppose, okay, or uh, you can say that suppose this is array name is capital X, and you take n elements x1, x2, x3. Okay, so these are the numbers, and xn, and these are the integers. Say you can take real, but I'm saying that these are the integers, and you have to means the array size is n. Now the question is, does there exist an element uh, xi which has occurred greater than equal to n by 2? Okay, so that means here uh, xi may occur in the array more than once. So if any element means, or I should define like this, say a number z is a majority if it occurs greater than n by 2. Okay, greater than n by 2. So if it is so, then we will call that element z as the majority element. Now our problem is to find whether a majority means instead I should write like this. The formal problem is that given a sequence of numbers, find the majority in the sequence. Sequence means array. In the sequence, or determine that none exists, because in an array there may not be any majority element. Okay, for example, suppose if it is so that 6, 2, 3, 6, say 6. So in this case you check that majority element is 6. Okay, here is a majority element is there, it is 6. And if there may be the case that there are no majority element. So as an application, suppose there is an election, a student elections. Now we are declaring that there will be a winner if means everybody see in the election what happens, that everybody gives the votes. So if and all of you may be the candidate. Please remember, it is not that only 2 3 the candidates are there. There may all of you may be candidate. So if anybody gets votes more than say n by 2, then but there isn't a majority, or some of the you also may be means as a candidate, few of you also think that we want vote. It is not there is no guarantee that all the persons will be candidate or few will be the candidate. Whatever will be the case, what I am saying, there will be a winner if uh, there is means if a person gets more than n by 2 votes. Okay. So anyway, so given we can simplify the problem like that, that there is an array of size n, and there are some elements which is occurring in the array, and we have to find out if an array element xi occurs in the array more than once. If it is so, then that xi will be called majority element. Okay, this will be the majority element. Now how can you solve this? Okay, so if you ask, I am not asking first the efficient one. Okay, so first you try to find out the solution for this problem using inefficient. Inefficient means time complexity may be large. So if I ask you that can you design a big O of n square algorithm for this, how can you do? How? Tell me. Very simple algorithm, big O of n square algorithm.
Or we
For
can go through the entire array, compare each element with the standard element, and find out the respective frequencies. And the one with the frequency that is greater than n
yes,
by
yes, yes. Thank you. That means I will first take. So I am not describing writing the algorithm here. Big O n square algorithm means suppose I am first choosing x1. Now x1 occurs how many times I can. That means I can find out the frequency of x1. Okay, and to find out the frequency of x1, I need n minus 1 comparisons. Okay, x1 with x2, x1 with x3, like this. So similarly I can find out the frequency of x2 with the by comparing it x2 with the others, find the frequency of x3. In this way you find out the frequency of all the elements, and if in the frequency of any element is greater than n by 2, that is called majority, fine, majority element. So uh, next, so this will take n square, fine. uh, Now we would like to improve this. So we go off n log n algorithm next. How can you find out?
So divide and conquer. So we can divide the array into like if we sorted the array and then divide it into two halves, and the one with greater amount of elements frequency would be the one which is
Now
greater.
then how can you conquer? See, what you are first step is correct, means you can sort the elements. Okay, you sort all the elements. First step is that you sort. In this case, sort the array. Then step 2 is the steps. Step 2, you uh, say uh, means after sorting the array, what you will do, you can just a minute, find, means if you sort the array, what happens? See, I'm just showing you. Say it may be like this. Say suppose 2 2 4 4 4 4, say 6, then maybe 7 7 7, in this way. Say suppose 11 11, in this way the sorted is, I am not writing all the elements. Now what happens? You find out the means where does it occur? Means you can find out where the element 2 occurs also. Means you can slightly change the binary search technique to find out the location of the first element A1. So for example, here you will get here. So you can find out what is the difference of this. Okay, means how many elements of 2 are there. So similarly, you can find out the these element. What is the last position of this in the array using binary search, because this is the sorted. If you slightly change the binary search technique, you can find out the location of position of the element 4 in the array, and you know the index of first 4 and the last 4, and you subtract it, you will get how many 4s are there. Fine. In this way, you see, if you would like to search an element in the sorted array, how much time it will take? We go of binary search for an element. Tell me. We go of log n. Is it clear? You can search an element from a sorted array in big of log n.
Yes, sir.
Then you are subtracting the position index first element and the means an element there may be duplicate element. Na? So you can find out the frequency of each element. Right? Now how many times you are searching? At most n. So n into log n. Clear? And you know the which has the more frequency, means greater than n by 2, that you can find out. That is n log n. Okay. Now if I ask you that we want more efficient. More efficient means we want uh, big O of n time linear time algorithm. Linear time algorithm. How can you do?
Could you just repeat about the step after the sorting of arrays, sir? What are we doing after sorting of arrays, sir? In the big of n log n
I
algorithm.
I I I am telling, just a minute. This thing you are saying. Yeah. I am saying that you search each element, first element, you after sorting 2. So after sorting means if you can modify. I have not explained. You can modify binary search slightly to find out the position of 2 again in the array. You try it in offline, then I will explain it. Okay. This is your homework. Means you may try that if there are multiple say numbers, how can I find out the last positions?
Yes, sir.
Okay, that can be done in. So I am not. I means in log n time you can find out the location of 2. Means location of 2 is here. Location of 2 is also here. I am asking the next position. Location of third element is here. Means third element is 4. 4 is here, and also another position 4 is there. I want the this 4. Sorry, not this 4. So the first index minus last index. My objective is to find out the last 4 and the first 4. First 4 I know, and you search whether what is the another position of 4. That using binary search I am saying like that. You need to modify. So in log n time you can find out another 4, and you find out the difference between these two index. What is the index of this? Suppose it is the index is array index is 10 and it is say 3. So 10 minus 3 plus 1. These many 4s are there. In this way, you compute the number of elements, frequency of all the elements. Now, my objective is to find out the solution in linear time. How can we find out the means these are the array elements? Again, I am writing here xn in elements are there, and we want to find out the majority element in linear time. So how can we do that in linear time? This is our objective. So can you tell me one, see please remember, this is one very important point. uh, Before designing the algorithm, always try to observe some property. If you can find out the property of property of the problem, if you can find out an interesting property of the problem, then you can solve the problem. I'm saying always try to characterize the problem. So I have said you that you find out the majority finding element. So, and according to our definition, what means what I'm asking you that can you find out any interesting property of the problem? Can you see yourselves? See, if there exists a majority element, then suppose okay, suppose there are 10 means whatever be the elements. Now you have you know the median. You find out the median of the array, and it needs how much time? Linear time. You already know this. Now, so once you find out the median, and if it is, you see, what is the median? Median means if I sort the array in this way, that less than equal to this, less than this, less than this. Okay, then if there is exist a median, sorry, if there exists a majority element, then you see that majority element will occur in the median. Yes or no? Tell me.
So, sir, repeat the statement once more, sir.
Tell me.
Could you repeat the statement once more, sir? What you said?
I am saying that you are, suppose there exists a majority in the array. Fine. Now you are finding out a median. What do you mean by median? Median means the element which occurs at the middle positions if I sort the array. Yeah. So after finding out the means, if there is a majority, if there, see, this is the sorted array. This is the sorted. This is the sorted. So majority is lying at the median. Now, if there is a majority element, that majority element means what? The element that has occurred at least n by 2 means more than n by 2. Is it clear? So
Yes, sir.
that means now from where it is starting. See, majority element may start from the first positions because all
Yes,
are
sir.
2, 2, 2. So then also median will it will pass through the median element. It may start through here. All these are elements are same. So this is majority element. So then it passes through the median also.
Yes,
It
sir.
may, is it clear? So what does it indicates? That means you find out the median first. Clear? Now you find out the median of the array, and then you count how many times that median element has occurred in the array. You count the frequency of the median. Okay, find out the median, then you find out the frequency of median. So if it is greater than n by 2, then it is majority. element. Is it clear? Otherwise not. Those who could not understand, I am saying for them. Is it possible, for example, see the figure again. Suppose this is the array, sorted array after sorting, and suppose this is the median. Tell me if it is sorted. Now, is it possible that the majority elements are occurring here and it is not crossing the median? Is it possible? Total n elements are there. 1, 2, 3. These are the index. Is it possible that only these majority elements are all are clustered here sequentially? It is not crossing the median. It's not possible because median lies at n by 2. But please remember, if I find out the median, don't I am not sure whether it is majority element or not. Why? Because there may not be any majority element. So that's why I have to count also the frequency of the median from the array. And then I will say, okay, it is majority element if its frequency is greater than n by 2, otherwise it is not majority element. Now tell me, is it very easy to find out the means to design find out the median of the array in linear time? You know, the algorithms means is not very easy, means it is slightly complicated. You know the time complexity, how we divided the array into five columns, okay, and then compute the median of median, then find out the approximate median by pivots, etc. Steps are there, recursive functions are there, and that is costly. You know the recursion means costly. Why? Because there will be so many times you will call the stacks. Stack size you will call the function and the stack size will grow, etc., etc., and it is not easy. So we want very simple algorithm in linear time to find out the majority of a given array. So how can we do that? That is a challenge. So now we will describe that thing. So first see, uh, this is the array x, x1, x2, x3. In this way, xn elements are there. Okay, so we are now going to discuss linear time algorithm. Simple linear time algorithm. Linear time means big O of n. Okay, big O of n. So how can we find out this? Now here also, what we will do, you see one interesting characteristic of this problem. Say you check, uh, if xi is not equal to xj. What is xi and xj? Suppose this element x2 is xi and say the one another element is xj. You just randomly select, for example, any two elements or sequential elements, it doesn't matter. And suppose if xi is not equal to xj, okay, and
Sir, you're not audible, sir.
I am writing. You
Okay,
can't
okay.
see?
Yes, sir,
Can
we
you
can
see
see,
that?
sir.
Yes,
I
yes.
thought you were speaking something while writing,
No,
sir.
no, 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 no. I am not saying. I am writing just because that at least I can share. I have no slide, but I can share the PDF. Means whatever I am writing, I can share with you later. Say I eliminate if they are not equal, then I will eliminate these two elements from the list, and then the say majority say in the original list in the original list remains remains a majority in the new list. This is the key observation. Very important. Check it. Let's see. Given an array, and if two elements are, say, suppose, better you take an example. It may be like this. Say suppose 5, 2, 3, 5, 5. Okay, this is example. So here you see 5 and 2, are they equal? See, in this case, does there exist any majority element? Tell me. Yes. Majority
Yes, sir. Yes, sir. 5.
5. Fine. Now 5 again. I am writing 2, 3, 5, 5. Now 5 is not equal to 2, so cut it. What is the list? 3, 5, 5. What is the majority element in the new list?
5.
5. So you see now the observation that if xi is not equal to xj and we eliminate both these elements from the list, then the majority element in the original list remains a majority. Clear? But please remember very important things that as a note. Okay, you can write that the opposite is not true always. The opposite may not be true. That means, say, example, 1, 2, 3, 5, 5. Does there exist a majority here? You check, no majority is there. Fine. Cut. First two numbers, they are not equal. I am removing them. Does there exist a majority here in the new list?
Yes, sir.
So you see the observation that there are no majority, but if you delete the two elements, I may get a majority which is false. Means although I am getting, so I need to check. Once I delete the elements, I need to check whether whether the new majority element was really a majority in the original group or not, original list or not. So therefore we'll take care of this. That means here you see, given an array, we'll just check whether the two elements are same or not. If they are not same, you throw out, and then again you start the rest of the element as a new array. For example, I am assuming that this is a new array. Again you check it, the two elements, are they same or not? Clear? If they are same, then I will use a counter, that how many frequency or multiplicity, whatever you say, that how many times it occurs. If it occurs more than once, say x1 equal to x2, then I will take this multiplicity is 2, means it has occurred 2 times. Then the third element, is it same? If it is so, then I will increase it. But if it is not same, then I will decrease the multiplicity. So what can be the algorithms? You see, uh, I am just writing the algorithm. The observation I have said. So algorithm, say majority. X is the name of the array, okay, and n is the element number of size. So you should write like this, say input. Please remember, this is the algorithm class. So whenever you will write any algorithm, you should describe. So X is what? An array of size n. Fine. And output majority the majority in X, the array. Okay. If it exists, if it exists, okay, or means if there are no majority, that minus one. Otherwise, we will return this. Now, so start. Say I am taking the first element as C, or just I am using this. I am assigning this, so I am just using this. C is x1, first element, and multiplicity means first element is occurring how many times? One times. Okay. So m is equal to 1. For say I equals, or say I should not write like C programming language. Sorry. I should write just like this. For I equals 2 to n, means it's increasing one by one. Okay. That's for I. So here what we will write, if say m equals 0, then C will be x I, ith element of the, I am explaining, just a minute. Say m will be again 1, else if C equals, this is not equal to I am not writing. See, please remember this arrow sign means assignment, and this single equal means say comparing. If C equals xi, then m will be increased by 1. Okay. Else m will be decreased by 1. Okay. Uh, if m equals 0, then majority that I would like to return. So in this case, majority will be -1. Sorry, I should write -1, not 1. -1. Okay, is the semicolon. Else count equal to 0, means I need to check how many times the majority element has occurred. Is it really majority or not? And for I equal to 1 to n, 2, if xi is equal to c, then count equals count plus 1. I am writing here count plus 1, just here, there is no space. I need to next. If just there is no space here. Actually, if it could, I could write here. I think it is not possible. Still, I am trying here. Just a minute.
Or you could reduce the zoom, sir. In that case, we could see both the pages together.
Okay. Okay, then let me write just two lines are there
Yes,
in
sir.
the
Yes, sir.
if count is greater than n by 2, then majority is C. Majority is C. Okay. Else majority is equal to -1. No majority exists. -1. Okay. And this will be the end. Now what you are saying that I should reduce. Can you see? I do not know. Do you have problem to see?
No, sir. No, sir. We can see, sir.
Okay. Then see what we are doing. Say you please try to visualize yourselves, because I cannot show the array again, because if I would like to show it, then it will. This is the x, means x is in above first.
Hmm.
Is x equal to x1 to xn. Okay, and uh, now what I am doing, say just I increase the page size then slightly here. This is the array that x1, x2, x3 dot xn. Okay. Now at first we take that this x1 as C, candidate. C for candidate means it may be the winner. Okay, candidate. C for candidate. Clear? And M means multiplicity. How many times it occurs? Multiplicity, sorry, city of candidate. So initially, I am considering only one, first one as the, so M equal to 1 and C is equal to this. Fine. Now what I will do, I will go to the next element. Okay, and I will check for I equal to, means what is the value of M? If M is equal to 0, that means it is the fresh array. If M equals greater than 0, that means I have already a candidate. I have already a candidate, and I should compare that candidate with this element, with this element. Fine. So if they are equal, that means this is the candidate, means for example 1 2, in example it may be like this. Say suppose 1 1 3 4. I'm not writing it in this way. Now this is C is this. Fine. And M is 1, number of 1. Now I am coming to here, then C becomes here you check this 1 equal to 1. So this 1 equal to candidate, so candidate's multiplicity will increase by 2 1, so it will be 2. Then I am coming to here, it is 3. 3 is not the candidate key, because candidate value is 1. So I should reduce this M to M minus 1, means M will be now 1. Then 4. 4 is, you see, still C equal to 1. Clear? Now 4. C equal to 1, but new value of xj is xi is 4. So they are not equal. So multiplicity values will be reduced to, again reduced, so it will be 0. So you see, this one is not equal to these three, this one is not equal to these four. So therefore I will start from the new array, as if the new array, the rest of the elements. So the multiplicity has become 0. And what will be the C now? If it is say 5, so these will be now C. Then again I will go on, means I will start like this. And once I finish the array, the multiplicity value may be some positive number or 0. If it is 0, that means there are no candidate key, means no majority element. I will immediately return. But there may be some positive value, maybe 5, 6, 1, whatever it may be. Then I have to check whether this is really a candidate key or not, by comparing how with all the elements, how many times it has occurred. So see the program now. Oh, yeah. C. C equal to 1 x1, and multiplicity value is 1. For I equal to 2 to n, if m is 0, that I told, then C will start from that next, that element xi. That will be the new candidate. And m is new, multiplicity value will be 1. Clear? Otherwise, what should I do? I should compare the candidate key with the xi. If they are same, then multiplicity values will increase by 1. If they are different, then multiplicity value will be reduced by 1. Fine. And I will go like this. And just a minute. Here it will be better if I write like this. Say yes. Yeah. See, this loop is from this to this if, and if this is the else part, the else part is this up to within else this. Fine. And for loop is from this to this. And now here you check, in this case that I have completed everything up to here. This now I am getting some value of m. So if m equal to 0, majority is -1. There exists no majority. But if m equal to greater than 0, means else part, that means there is a possibility that that may be a candidate key, may not be. So what I have to do, that I told now, that there may be a false majority. So I have to actually check it, that how many times it has occurred. So count, I will take a counter value, count equal to 0, and for I equal to 1 to n, I will count how many times it has occurred. Count means if xi equal to c, that c means candidate key, then count will be count plus 1. Fine. In this way, I am just going to count it. And if count is greater than n by 2, then you may return the majority. Majority will be c, else the majority will be -1. Finished.
Yes, sir.
Is it clear now?
Yes, sir.
Now, how many total comparisons are required? How many total comparisons are required?
So, once when we are finding out m,
So to find out the candidate, first you tell me how much time does it take to find out this majority. Means here it may be true or false, but you see, you are just comparing the first two elements, then second, third, fourth, fifth, sixth, like this n-1 comparisons to find out a candidate. Is it okay or not? To find out the candidate in this step only. Here, I need only n-1 comparisons. And n-1 comparisons to check whether that is really a majority or not. So that means we can write that we, okay, I should now enlarge it. We use n-1 comparisons find a candidate and is a majority or not. Okay. So at most 2 into n minus 1 means 2n minus 2 comparisons are required. So time complexity, it will be linear. So therefore time complexity is now which one is easier to write the code for this one or using linear time median finding? Tell me.
It's a median finding, sir.
Median finding.
So
So
sorry, sir.
this
Sir,
one.
this one, my bad.
This is very easy because there are no recursion, no need to split the array into a group of five size of fives. Okay, so this is easier. There you need to find the selection sort. There is a constant part. So
Yes, sir.
so that is more costly. Although they are both of them are linear, that is more costly. Okay.
Yes, sir.
Now I am this you should know, and there was a still a chance of means number of comparisons was reduced by Fisher in 1982, and they obtained 3n by 2 plus 1 comparisons total. Okay, but anyway, that is also linear, but that is the optimal. Means it can be this can be further sub reduced. So if you are interested, you may see, but it is not required. For example, is they have the paper, Fisher and another one, Salberg. In 1982, they have shown that it is possible to reduce the number of comparisons to 3n by 2 plus 1. Okay, and that is optimal. No one can reduce further. But anyway, that is also linear, but it is better in terms of constants. 3n by 2 plus 1 means 3 by 2 is the constant. You see, here we are getting 2 into n minus 2, but it means the factor which is multiplied by n is 2, and in that case, in their case, 3 by 2. Okay. So it is these types of algorithms means are means you always see that how to means use some characteristics. Okay, how to use some characteristics to solve a problem. You try to find out the observations from the problems. Now I am just giving so another problem you may think I'm not saying the solution. Skyline problem. Just I'm saying, uh, if you have, say, mm, suppose there is like this, say, this one. Okay, these are the buildings. You know, na game. You play some video games. I'm
Yes, sir.
play or don't play. Very good boy,
Yes, sir. It's a good place, sir.
but don't be addicted. Say like this. These are some buildings. I'm not drawing too much. So these are the buildings, and they have the see, all say are lying that their baselines are same. Okay, their baselines are same means this. Now, we want to find out the skyline. Skyline means what? See, I want to know, this will be the skyline. This you check, these, these, then these. I cannot. This will be the skyline. I want to find out this one. In this way. So any building means, what will be the input? What is the input? Input is like this.
Only height, sir.
Input is only, no, input is just like this, a building, na?
Yes,
So here, suppose say this is xi, this is xj, and this is the height. This height is h building. So input for this building will be like this: xi, comma h, then xj for this building. So in this way, n buildings are given. Clear? N number of buildings. So how many coordinates? 3 n coordinates are there. Xi, x value of I, xh, then this. And what will be the output? Output, you know that first say this value, then height, then this value, then height means how much height is this. Say if it is say h1, this one, and this is suppose h2, and suppose this building is h3, this is h4. No, so not h4. This is h4, and this is h5. There are 5 buildings, I think. 1, 2, 3, 4, 5, right? And their coordinates. So here you see, and if it is say 2, I'm just writing 2, 4, 6, maybe 10, 12, 20, 30, 35, 40, 80. These are the coordinates. So what will be the output? Output will be like this. Means,
sir, will you eliminate the lines in between, sir? Like the
skyline means that you can see here. You see,
yes, sir.
no
Yes, sir. The lines in between, as in the building lines, sir. Like
building.
for example, H5 or H4. Those
Yes,
lines, sir.
yes. You have your output will be like this. You see,
Yes.
2, then H1. H1 has a value. I am not writing 2 H1. Then 6. 2 H1 6. Then it will be its height is H2. Then it will be, you tell me 10. Then H3. Then it will be 30. Then it will be H4. H4. Then it will be 35. Then it will be 35. After that H5. Then 40. Then it will be H4. And then 80. Clear?
Yes, sir.
In this way, this will be the output. And your it should be n log n.
Yes, sir.
No need to draw anything. You just give the input like this. 3 encode is C. You write a C program. You write a logic first, then you do that. Try to using divide and conquer. I'm just telling the hints. This is the hints. Okay.
Okay, sir.
So we stop here. Okay. Thank you for cooperating.
Thank you, sir.
Okay. Do you need this or you don't need? Just tell me. Means video I will
Sir,
upload.
sir, it would be very